So here is another example of an unbalanced redox equation. So I'm just going to go through the steps again so that you can know how to balance any redox equation. So in this case, as we said before, the first step would be to separate this into two half equations. So the first half equation would be MnO4 minus to form Mn2 plus, and then Fe2 plus to form Fe3 plus. Okay, so that's the first step. Separate it into two half equations. The next step is that we balance all atoms excepting hydrogen and oxygen. Now in this case, that would mean we balance the manganese, but it's already balanced, so therefore we don't need to make any changes there. And the same is true in the case of the second half equation for the iron. It's already balanced, all right? So we move on to the next step, which would be to balance the oxygens. And you'll notice that there are 4 oxygen atoms on this side. There are none on this side. And as we said before, we balance the oxygens by adding the correct number of water on the side which has the fewer number of oxygens. So in this case, we would add 4 water molecules on the right. In the case of the second half equation, there are no oxygens, so therefore there's no need for us to add any water to any side. So that leads us now to the next step, which involves balancing the hydrogen ions. And you'll notice here, for the first half equation, there are 8 hydrogen atoms. So therefore we need to add 8 hydrogen ions on this side. And then we look at the second half equation, there are no hydrogens, so therefore we don't need to balance the hydrogens in that case. So that leads us now to the next step, where we balance the charges. Now the bottom equation is very easy to balance in terms of charges, because you have a +2 here and a +3 here, and if you remember from the previous example, we simply add electrons to the higher charge side, which in this case would be the right side, and therefore we just add 1 electron, we add 1 electron to that side, so that the total number of charges here would be +3 minus 1, I'm sorry, equals to +2, which balances with the +2 on this side. Now for the second or the first half equation, you have a total of +2 charge here. We have a total of 8 plus charges minus 1, so that's +7. To balance the charges, I would add 5 electrons to this side, because by adding 5 electrons to this side, we're adding 5 negative charges, which reduces the total from +7 to +2. So we have +2 on this side, +2 on that side, so the charges are balanced for the second half equation. Now, what I would do next is to ensure that the number of electrons lost is equal to the number of electrons gained. So in this particular case, all I would do, I would simply multiply this equation by 5. So we're going to end up with 5 Fe2 plus to give 5 Fe3 plus 5 electrons. All right? And what I'm going to do to avoid confusion is cross out this, and I would simply add the 2 equations. This one, I'd add this equation here and this equation here, and the only thing is going to cancel out between them would be the 5 electrons here and the 5 electrons here. So therefore I simply will write down what is left, which would be 8 hydrogen ions plus MnO4 minus to give, oh, by the way, forgot to add the 5 Fe2 plus here. And then on the right side, I will have Mn2 plus 4 water molecules to give, well, plus 5 Fe3 plus sorry about that, Fe3 plus. And as I said before, the only other thing that's left for us to do is to make sure everything is balanced. So let's do that, starting with the hydrogens. We have 8 hydrogens, 8 hydrogens. We have 1 manganese, 1 manganese. We have 4 oxygens, and 4 times 1, 4 oxygens. We have 5 irons, and then as far as the charges are concerned, we have 8 plus charges minus 1, 7, 7 plus 10, 17 plus charges, and then on this side we have a plus 2 here, and we have 5 times plus 3, that's 15, so that will give you plus 17 as well. So everything is balanced, including the charges. All right, okay, so that's it for this video.